Right, question number 4. Experiments show that if the chemical reaction, so we've got N2O5, so dinitrogen pentaoxide, and we have 2NO2 plus half O2, takes place at 45 degrees Celsius. The rate of reaction of dinitrogen pentaoxide is proportional to its concentration C, with proportionality constant equal to minus 0.0005, and we need to find an expression for the concentration of dinitrogen pentaoxide if the initial concentration is C0. So let's have a look at this question. So first of all, let's let C, capital C, be the concentration of dinitrogen pentaoxide. So it's already stated according to the question, but anyway, let's let C be the concentration of dinitrogen pentaoxide. So let's use the chemical formulas N2O5. And using this letter which has been assigned to us, let's create a differential equation. So it says the rate of dinitrogen pentaoxide, so the rate of this reaction, so rate refers to d by dt, rate refers to the rate with respect to time, so in this instance dc over dt, and that is proportional to, the concentration, so the concentration which is C. Now let's get rid of this proportionality, so dc over dt, so that is equal to kc, so k is our proportionality constant, so let me note that down. So we have our differential equation, and we also have the proportionality constant, so in this case k, so k refers to the proportionality constant, that is equal to, bearing in mind, minus 0.0005. So k is minus 0.0005. So let's make a note of that. So according to the question, we need to find an expression for the concentration of N2O5 if the initial concentration is C0. Let's solve this first order differential equation. So we have a first order differential equation here. First order differential equations can be solved by using separating the variables. So let's use the method, so by separating variables. So I'm going to bring this C and dc term, and we'll take that to the left hand side. So in particular, if I bring this C to the left, I'll have 1 over C dc. So my C and dc terms are to the left hand side of this equation. Keeping the K on the right, so K, but bringing the dt to the right, so K d small t. So after separating the variables, let's integrate both sides. So let's integrate, both sides. So let's integrate the left hand side, so 1 over capital C d capital C. And let's integrate the right hand side, so K d small t. So if we integrate the left hand side, if we integrate 1 over capital C, we'll get lnc rather. So if I move down to the next page, so we're going to get ln C, and that is equal to, and if I integrate, if I integrate K with respect to T, so let me zoom in a little bit. Integration of K with respect to T is KT, but don't forget to add a constant of integration, so it's KT plus, and let's say small c So in this case, so it's going to be a kt plus, let me use c dash. So c dash is our integration constant, so I'm using c dash in order to distinguish that from this c here, which is the concentration of N2O5. So let me make a note in the corner. C dash here is our integration constant. Right. So in this case, let's go one stage further. Let me rearrange for capital C the concentration of N2O5. Capital C, if I rearrange, is e to the kt plus c dash. And let me separate this exponential term. So let me show you what I mean. So I can rewrite this as e to the kt times e to the c dash. So this can be done by using the multiplication law of indices. So remember the law, if you multiply two terms having the same base, we add the powers. Now, further to that, if I take a red pen, c dash is a constant, so it's an integration constant. So I can replace e to the c dash, which is also a constant. So we can replace e to the c dash by another constant, which I'm choosing to be capital D. So if I let capital D be e to the c dash. So with that being said, I can rewrite this equation here as capital C, which is D e to the kt. So here is our solution as it stands with capital D. Remember, capital D is e to the c dash. C dash is a constant, so I've replaced e to the c dash, also a constant, by capital D. Now, if we go back to the question, it did say that the initial concentration, so if I refer to this part of the question, the initial concentration is C0. Initial meaning the concentration at the time t equals 0. So when t equals 0, the concentration of N2O5 is C0. So let's apply this initial condition to this equation that we have. So in this case, here's our initial condition. When t equals 0, C is C0. So if I replace in our equation here, so C is C0, that is equal to capital D e to the k and t replaced by 0. Now k times 0 is 0 and e to the power 0, so that amounts to 1. So in this case, we're going to have D, so D times 1 being D, D should be C0. So that is the answer, the solution to capital D. But let's not stop there. Let's replace that value into the previous equation, this equation that we have here. So let's do this final replacement. So let me go back to my favorite color, blue. So if I replace capital D here by C0, this is what we're going to have as a result. We're going to have C, that is equal to capital D, which is C0 e to the kt. Now we have the value of k. So if we go back to the question, the proportionality constant is equal to minus 0.0005. So we made that note here. So let's replace that k by minus 0.0005. So let's have a look. So in this case, k is minus 0.0005. So if we perform that replacement, we're going to get C0 e to the k being minus 0.0005 k t rather. So this is the solution that they're looking for. So if we go back to the question, this is exactly what they need. So they want an expression for the concentration of nitrogen pentaoxide, or N2O5, if the initial concentration is C0, and this is exactly what we've done here. Okay, so I hope you found this video helpful. I hope you enjoyed the video. If you did enjoy the video, be sure to subscribe, and I hope to see you again. Thank you.